All right, so the first thing you guys are asking about is the slant asymptote. So let's start with that. When we find the slant asymptote, we're looking for the equation of a line. So that's really important to remember. So the slant asymptote is always going to be of the form y equals mx plus b. Okay, so I know that once I figured out what the slant asymptote is, once I have the equation of a line, I can stop. Doesn't matter if I have filled in every box in this thing that I'm going to create. Doesn't matter at all. I just have to create the equation of a line. So to do that, I need to start by taking what I'm dividing by. So in the bottom of my fraction, what I'm dividing by, that's this. And that's going to go on the side of my box. So when I create my box, I know I have to have 3x squared minus 9x on the side of it. Now, my box will have, it looks like 2 rows. Okay, so I'm going to create my box with 2 rows, and I know that because I have 2 terms in my polynomial that I'm dividing by. And if you're not sure how many columns to make, just look at what it is that you're actually dividing. So what's in the top of your fraction, in the numerator of your fraction, and make that many columns. You probably won't need them all, and that's okay. But I'll go ahead and just, it's a good starting point if you're not sure what to use. Now I'm going to write the rest of that function. So, or not the rest of the function. I'm going to write the original function on top of my fraction down below. Plus 4x. Now, what I didn't say, but what's really important to remember to check for, is that your exponents are going in order from largest to smallest, and you're not skipping any. So I start with x cubed, and then the next exponent I would expect to see would be x squared, and then x to the first, and then we'd have a constant term if necessary. It's not necessary to have your constant term. If you really want to write a plus 0 there, you can, but you don't have to. And then I would make sure of the same thing here. So I have 3x squared. The next exponent I would expect to see would be 1. I have that, so I'm good. Again, the constant term isn't always necessary. So now I start the process. And the reason I set up the box the way I did is because these boxes are going to correspond to the different terms in the polynomial in my numerator. So what I'm seeing here is that I've tried to highlight them so they match the color of the polynomial that I wrote below, but I'll even highlight up top too. So the x cubed, negative 5x squared, and then plus 4x. So we've got those 3 colors that we're going to see inside the box. And what's important to remember is that the boxes that are diagonal from each other will have the same exponent on x. And they have to combine to give you what's in the original polynomial in the numerator of your function. So to start the whole process out, I take the first term from my numerator, which is x cubed, and I put it inside my box. Now I have to ask myself, I know this side of my rectangle is 3x squared, this little piece right here. And then what I have to figure out is what would this be so that when I multiply 3x squared by this, I get x cubed. There's a couple of ways that you can do that. If you're able to just say, hey, something times 3x squared is x cubed, and you just know what that is, perfect. If you aren't able to do that, what you can do is you can take what's inside x cubed and divide by what's outside 3x squared. Now, what we know from that is that we're going to get x cubed divided by x squared. There's a giant 1 in there that we could reduce, which is just going to end up being x, and then 1 over 3. So what I know is that up top here, I'm just going to have 1/3 x. Again, that's because 1/3 x times 3x squared will give me x cubed. That's what I'm trying to force to happen here. So now I've got it. The first part of my equation of my line matches up here. mx, we have the mx part. Now we got to figure out what the plus b part is. So to do that, once I have this 1/3 x, now I know that's the length of this portion of our rectangle. So what I know is that this is 1/3 x, this is negative 9x. I can figure out what goes here now, because 1/3 x times negative 9x is going to be negative 3x. I need to use blue, not green. Negative 3x squared. Okay? And then the reason I color-coded is because what we remember is that these two have to add up to whatever we have in the numerator of our fraction. So we know that something minus 3x squared has to give us negative 5x squared. Well, that means that in this box, we need to have negative 2x squared. And then we start that process over again, right? I know this is 3x squared. So something times 3x squared, something times 3x squared should give me negative 2x squared. And I can do the same thing I did just a moment ago. I can take that negative 2x squared and divide it by 3x squared. And that's going to give me what I'll write at the top of my box. All right, so that's going to give me, there's my giant 1, I just get negative 2/3. And that's what'll go right here. That is the equation of my slant asymptote, because now I have the mx portion and I have the b portion. I've got the equation of my slant asymptote. So if I write the equation, it's just y equals 1/3 x minus 2/3. So I just want to take a second and address end behavior, because there's a lot of questions about that. Your slant asymptote is directly tied to your end behavior. So if I want to find the end behavior of this, we know that we set it up every time the same way. As x approaches negative infinity, y approaches something. And as x approaches positive infinity, y approaches something. The something that gets filled in there, that's either your horizontal asymptote or your slant asymptote every time. I could literally give you a horizontal or slant asymptote and ask you to write the end behavior without showing you a picture of the graph, without giving you the equation, and you could write the end behavior. So the end behavior is just going to be what I just found for my slant asymptote, which is 1/3 x minus 2/3. And that's it. All right, the next video will address holes.